February 17, 1944, Aprilia, Italy. An American combat engineer named John Toffey crouched in a drainage ditch beside Route 7, watching a German Tiger tank idle 200 meters away on a stone bridge that had stood since the reign of Mussolini's grandfather. He had 12 pounds of composition, B explosive, a roll of industrial adhesive tape, and an idea no one had written into any manual. The Anzio beachhead was dying. 56 days after the amphibious landing that was supposed to outflank the Gustav Line and open the road to Rome, 36,000 Allied troops sat pinned inside a perimeter the size of Manhattan, absorbing artillery fire from the Alban Hills, while German counterattacks threatened to push them back into the Tyrrhenian Sea. General John Lucas had landed with overwhelming force on January 22nd, two reinforced divisions, British and American, supported by naval gunfire that could reduce a hilltop to rubble in minutes. The invasion met almost no resistance. The beaches were nearly empty. The road to Rome lay open, and Lucas didn't take it. He consolidated the beachhead instead, building supply dumps in defensive positions while waiting for reinforcements that wouldn't arrive until the Germans had time to react. By January 25th, 8 Wehrmacht divisions were racing toward Anzio. By January 30th, the window had closed. Now the Allies were trapped. The Wehrmacht had moved the 26th Panzer Division into the salient, along with elements of the Hermann Göring Division and the 715th Infantry Division. With them came the Tigers. These weren't the hollow propaganda monsters of newsreels. They were 70-ton moving fortresses, each mounting an 88mm main gun capable of penetrating 4 inches of armor plate at 200 feet per second, 1,000 meters, protected by frontal armor, the thickness of a phone book that shrugged off American tank rounds like hailstones. The Tiger. I had entered service in August 1942, designed specifically to outmatch any Allied tank on the battlefield. It cost 650,000 Reichsmarks to build, roughly twice the price of a Panzer IV, and required 3,000 man-hours of skilled labor to assemble. Germany produced exactly 1,385 of them during the entire war. Each one was irreplaceable, and each one was a nightmare. Intelligence counted 14 Tigers operating in the Anzio sector. Every one of them had become a catastrophe waiting to happen. On February 16th, a single Tiger had destroyed 4 M4 Shermans in 11 minutes near Caricedo, firing from a hull-down position the Americans couldn't touch with anything short of close air support, which the weather had grounded for 3 straight days. The Sherman crews never had a chance. American tank doctrine relied on mobility and numbers, the idea that you could overwhelm a heavier enemy by attacking from multiple angles simultaneously, forcing him to divide his fire. It worked against Panzer, 3s and 4s. It failed catastrophically against Tigers. A Sherman's 75mm gun could penetrate roughly 3 inches of armor at 500 meters, assuming a perpendicular hit. The Tiger's frontal armor was 4 inches thick, sloped at 12 degrees. You needed to be within 300 meters to have any chance of a kill shot. The Tiger could kill you at 2,000. The math was simple. The outcome was predictable. The bridge at Aprilia mattered because it carried the only paved route into the northern shoulder of the beachhead perimeter, a 2-lane road that connected the coastal highway to the inland villages where German artillery observers directed fire onto the beaches. Lose that bridge, and German armor could sweep down the coastal highway unopposed, cutting the beachhead in half and isolating the British X-Corps from the American 6th Corps. Hold it, and you forced the Tigers into marshy ground where their weight became a liability, where the soft soil turned into a trap that could bog down a 70-ton vehicle in seconds. Corps engineers had wired the bridge with demolition charges on January 29th, standard doctrine, textbook preparation. 6 20-pound cratering charges placed at the base of each pier, connected by detonation cord and rigged to a dual firing system, electrical and manual, with redundant igniters buried in waterproof canisters 50 meters from the bridge. The Germans cut the wires on February 3rd. Not randomly, deliberately. A combat engineer team had crawled out at night, traced the detonation cord back to its source, and severed every connection. They left the charges in place, perhaps as a trap, perhaps as a taunt, but rendered the entire demolition system useless. A second wiring attempt on February 9th, ended when a sniper killed Lieutenant Daniel Marcus, the officer carrying the blasting caps, before he reached the span. Marcus had been 23 years old, a civil engineering graduate from Cornell who had joined the Army in 1942 because he believed engineers had a moral obligation to serve during wartime. He died face down in the mud with a bullet through his chest, 10 feet from the bridge he'd been ordered to blow. No one tried to wire it again. Now, a Tiger sat on that bridge, engine idling, commander's hatch open, covering the approach while a repair crew worked on a blown track link that had separated during the previous night's movement. The tank was Tactical Number 221, belonging to the 508th Heavy Panzer Battalion, a unit that had been formed in May 1943 specifically for deployment to critical sectors where standard armor couldn't achieve breakthrough. The 508th had fought at Kursk, then been transferred to Italy in December after the Soviet counteroffensive had eliminated any hope of German victory in the East. They were professionals, veterans, men who knew their vehicle and trusted its armor the way sailors trust a good ship. Toffey had been a construction foreman in Pittsburgh before the war, supervising bridge repairs for the Pennsylvania Department of Transportation. He understood load-bearing structures the way a pianist understands keys. He knew that the bridge's main strength came from 3 limestone arches, each supporting roughly 30 tons of distributed weight, and that the Tiger, idling directly above the center arch, was applying a point load the 18th century masons had never imagined. The bridge had been built in 1804 during Napoleon's occupation of Italy, part of a road network designed to move French artillery from the coast to the mountain passes. The limestone had come from quarries near Tivoli, hauled by oxen and shaped by stonemasons who learned their trade building aqueducts under masters who had learned from masters stretching back to the Roman Empire. It was solid construction, but it hadn't been designed for tanks. Toffey also knew that conventional mines wouldn't work. American anti-tank mines, designated M1A1, required pressure detonation. You buried them in roads and waited for a vehicle to trigger the fuse. The standard mine contained 10.5 pounds of TNT packed into a circular steel case 8 inches in diameter. You needed 300 pounds of pressure applied directly to the pressure plate to fire the detonator. It was effective against any vehicle with treads or tires, but you couldn't bury a mine on a bridge deck. The stone surface was solid, impermeable. You'd need jackhammers to cut a recess deep enough to conceal the mine, and the sound would alert every German sentry within 500 meters. And even if you could somehow place a mine under the Tiger, the crew would see you coming across 200 meters of open ground and cut you in half with the bow machine gun before you got within throwing distance. Toffey's idea was simpler and insane. If you couldn't bury the mine, you stuck it on. The concept had existed in theory since 1940. When British commandos experimented with magnetic anti-tank grenades for use against parked vehicles during sabotage operations in occupied France. Those devices, officially designated number 74 ST grenades, nicknamed sticky bombs by the troops who hated carrying them, used a glass sphere coated in adhesive wrapped around 1.5 pounds of nitroglycerin. You peeled off a protective cover, smacked the grenade against a tank's hull, and ran like hell before the 5-second fuse expired. They had been a comprehensive disaster. The adhesive failed in cold weather, becoming brittle and losing all tackiness below 40 degrees Fahrenheit. It stuck to the thrower's uniform in hot weather, occasionally adhering to a soldier's sleeve or trouser leg and refusing to release, which meant the grenade exploded while still attached to the man trying to throw it. The glass sphere shattered unpredictably during rough handling, which meant transporting the grenades required special padded crates that took up valuable cargo space. And even when everything worked perfectly, the explosive charge lacked sufficient power to penetrate even light armor. The grenades could damage external equipment, periscopes, tracks, antenna mounts, but rarely achieved a kill. The British War Office quietly withdrew them from service in 1943 after concluding they were more dangerous to friendly troops than to the enemy. But Toffey wasn't thinking about tank hulls, he was thinking about stone. The underside of the bridge arch was dry-laid limestone, mortared with lime-based cement that had spent 140 years absorbing moisture from the river below. That made it porous, rough, microscopically irregular, an ideal surface for adhesive bonding where the tape could flow into the tiny surface irregularities and form a mechanical interlock that was stronger than either the adhesive or the stone alone. And he had something better than the British glue. In his pack was a roll of what the Quartermaster Corps called pressure-sensitive adhesive tape, Type 3, a rubberized fabric tape developed by Johnson & Johnson in 1942 for sealing ammunition boxes in tropical climates, designed to maintain its bond in temperatures ranging from -40 to +120 Fahrenheit and in humidity up to 95%. The tape consisted of a cotton duct cloth backing coated with a polyethylene-based adhesive that remained tacky indefinitely and could support a shear load of 35 pounds per square inch. It was 2 inches wide, came in rolls of 60 yards, and cost the Army 4 cents per yard. Soldiers called it duct tape because water rolled off the polyethylene coating like rain off a duck's back. Engineers called it a miracle. Toffey's plan was to tape 12 pounds of composition B explosive directly to the keystone of the center arch, 20 feet below the Tiger's treads, then detonate the charge with a time delay fuse that would give the man placing it 90 seconds to clear the blast radius. It wasn't in any field manual. It probably violated 3 separate sections of the Demolition Handbook, which explicitly stated that adhesive attachment was unreliable and should never be used for critical demolition tasks. And it might be the only way to drop 65 tons of German steel into a river without exposing a man to machine gun fire for the time it would take to cross 200 meters of open ground. He briefed the concept to Captain Robert Kellogg, commanding officer of Company A, 36th Engineer Combat Regiment, at 0400 hours on February 17th. Kellogg listened in silence, standing in a sandbag dugout that smelled of wet earth and stale cigarette smoke, studying the hand-drawn diagram Toffey had sketched on the back of a ration box. Then he said, "You'll need a swimmer." The Gari River ran 15 feet below the bridge, swollen with February meltwater from the Apennines, current moving at approximately 4 knots, fast enough to make swimming upstream impossible, slow enough that a strong swimmer could control his drift. The only way to reach the underside of the arch without crossing open ground was to enter the water 300 meters upstream and float down in darkness using the current to carry you silently past German listening posts that had been established at 50-meter intervals along both banks. You'd be in water cold enough to induce hypothermia in under 12 minutes. You'd be working overhead, arms extended, fingers numb, trying to apply tape and set a fuse by touch while a Tiger tank idled 8 feet above your head and German sentries paced the bridge deck 20 feet above that. And if the sentry on the bridge heard anything, a splash, a cough, the scrape of a boot on stone, the rustle of waxed canvas, you'd die in the river without ever surfacing, shot by men you'd never see. Toffey said he'd do it himself. Kellogg said no. Not because Toffey wasn't qualified. He was one of the best demolition men in the regiment, with a perfect safety record and a reputation for solving problems that made other engineers shake their heads. But because the man who designed the bomb shouldn't be the man who placed it. If something went wrong, if the adhesive failed or the fuse malfunctioned or the blast didn't achieve the desired effect, the Corps needed someone who understood the theory, someone who could analyze the failure and design a better solution. That someone was Toffey. He assigned the swim to Private First Class Eugene Courtney, a former lifeguard from Santa Monica who had survived the Salerno landing in September 1943 and volunteered for every miserable detail that involved cold water because, he said, it reminded him of home. Courtney had spent 4 summers working the beach at Santa Monica Pier, pulling drowning swimmers out of riptides and teaching children how to float. He'd learned to read water the way other men read maps, understanding current and depth and temperature by watching the surface patterns, knowing where the dangerous spots were before he entered the water. He'd enlisted in December 1942, 2 days after his 19th birthday, because he wanted to fight and because staying home felt like cowardice when other men were dying. Courtney received the mission brief at 0430. He had 2 hours to memorize the river approach, test the waterproofing on the explosive package, and rehearse the fuse sequence until he could do it blind. At 0600, Toffey and Courtney moved to the insertion point, a collapsed culvert 300 meters upstream from the bridge where the riverbank provided concealment from observation. The sky was the color of slate, overcast with low clouds that promised rain before noon. Good weather for the mission. Rain would mask sound and reduce visibility, giving Courtney better odds of reaching the bridge undetected. The explosives were packed in a rubberized haversack with a welded seam, manufactured by the Goodrich Tire Company and tested to a depth of 30 feet without leakage. Inside, 3 4-pound blocks of composition B, each block wrapped separately in waxed canvas, bundled together with friction tape, with a blasting cap seated in a hole drilled into the center block. Composition B was a mixture of RDX and TNT, roughly 40% more powerful than TNT alone, with a detonation velocity of 26,000 feet per second. It was stable, reliable, and, critically, waterproof. You could submerge it for hours without degrading its performance. The fuse was a length of time delay cord, officially M700 fuse delay demolition, that burned at 30 seconds per foot, enclosed in a waterproof plastic sheath that protected the pyrotechnic core from moisture. Toffey cut a 3-foot length, which gave 90 seconds from ignition to detonation. 90 seconds to swim 100 meters, 90 seconds to climb a muddy bank, 90 seconds to find cover before 12 pounds of military-grade explosive converted the center arch into gravel and dropped a tiger tank into a river. At the downstream end of the fuse, he crimped a standard number, 8 blasting cap, a small aluminum cylinder containing a primary explosive charge sensitive enough to be ignited by the burning fuse and powerful enough to detonate the main charge. At the upstream end, he attached a pull-wire igniter, a simple mechanical device that used a spring-loaded striker to ignite a percussion cap when you pulled a wire ring. One tug, and the clock started. The tape went around the outside of the package. 6 complete wraps, adhesive side out, protected by a peel-away paper backing that Courtney would strip off underwater just before pressing the charge against the stone. They test-dunked the package in a water-filled shell crater to verify the seal. It floated, too buoyant. If Courtney released it underwater, it would bob to the surface like a cork, visible to anyone on the bridge. Toffey added a 2-pound iron sash weight wired to the bottom of the package with 18-gauge steel wire. Now it sank. Perfect. At 6:20, Courtney entered the water. He wore a wool undershirt, still damp from the previous day's rain, fatigue trousers, boots with the laces double-knotted, and a canvas belt holding a trench knife and a signaling mirror in case he needed to communicate with observers on the friendly side of the river. No helmet, no pack, no weapon heavier than the knife. The haversack rode on his chest, suspended by a neck strap bobbing just below his chin. The cold hit like a fist. The Gary in February ran at 42 degrees Fahrenheit, cold enough to steal your breath, cold enough to lock your muscles into rigid paralysis in under 5 minutes if you fought the current and burned energy trying to swim fast. Courtney didn't fight. He let the river take him, arms trailing, legs drifting, face turned skyward to keep his mouth above the surface, watching the stars fade as the false dawn turned the sky the color of gunmetal. The current carried him past 2 German outposts. He heard voices, low, bored, speaking a language he didn't understand, but no one challenged the dark shape floating in the water. A submerged log, perhaps, a dead animal. Nothing worth investigating in the minutes before dawn when your shift was almost over and you were cold and tired and thinking about breakfast. At 6:38, he saw the bridge. It appeared first as a black line across the sky, then resolved into 3 arches, the center one broader than the others, limestone blocks fitted so precisely that even after a century, the mortar joints were thinner than a pencil line. The Tiger was a shadow above the center span, exhaust smoke drifting east on the morning breeze, carrying the distinctive smell of German diesel fuel, harsher and more acrid than the American variety. Courtney kicked twice, angling toward the upstream face of the arch, and let the current pin him against the stonework. The keystone was a wedge-shaped block at the apex of the arch, 2 feet wide, 3 feet deep, carved from a single piece of limestone and fitted so precisely that it bore the entire weight of the span above without mortar. Textbook target, remove that stone, and the arch had no structural integrity. He braced his boots against a lower block, reached up with both hands, and pressed the haversack against the keystone's rough surface. Then he began peeling away the paper backing. The tape came free in strips. Cold had stiffened the adhesive slightly, making it less tacky than it would have been at room temperature, but it still grabbed, clinging to the limestone with a grip that felt permanent. Courtney worked in darkness, fingers numbing, stripping paper and pressing tape, building up layers, wrapping the package until it hung from the arch like a wasp nest, secure enough that the weight of the explosive wouldn't tear it loose. Above him, the Tiger's engine note changed. Someone was revving the throttle, testing the repairs, preparing to move. Courtney froze. If the tank moved, the bridge would shift. Only fractionally, only a millimeter or two as the weight redistributed across the span, but enough to crack mortar, enough to send dust sifting down into the water, enough to tip off any sentry who happened to be looking down. The engine settled back to idle. Courtney resumed work, hands moving faster now, aware that time was running out, aware that dawn was coming, and with it, the end of darkness and the end of concealment. At 0641, the package was secure. He found the igniter cord by touch, traced it to the pull wire ring, and wrapped his fist around the cold metal. One tug, and he'd have 90 seconds to swim 100 meters downstream, climb the muddy bank and reach cover before 12 pounds of military-grade explosive converted the center arch into gravel. He tugged. The igniter popped, a tiny sound like a dry twig snapping, and the fuse began to burn inside its waterproof sheath, invisible, silent, consuming itself at exactly 30 seconds per foot. Courtney pushed away from the bridge and swam, not splashing, not thrashing. Long, smooth strokes angling across the current, aiming for a stand of reeds on the east bank that Toffey had marked on the map as the extraction point. 60 seconds. His arms felt like lead, the cold sapping his strength, turning his muscles into dead weight that barely responded to commands. 45 seconds. The bank was still 30 meters away, impossibly far, and his arms were slowing, each stroke weaker than the last. 30 seconds. He stopped swimming and let the current take him, conserving what little strength remained, drifting, trusting the river to carry him clear of the blast radius. 15 seconds. He reached the reeds and pulled himself into the mud, rolled onto his back, and tried to breathe without shaking. His body was shutting down, hypothermia creeping in, but he was alive. And he was clear, and that was enough. 0. The explosion was a physical thing, a pressure wave that traveled through the water and slammed into his chest like a giant's fist. It didn't sound like thunder. It sounded like a building collapsing, a deep crumping roar that rolled across the beachhead and echoed off the Alban Hills, followed by the secondary crack of breaking stone and the drawn-out shriek of metal twisting under stress that shouldn't exist. Courtney sat up, water streaming from his uniform, and looked back at the bridge. The center arch was gone, not damaged, not cracked, gone. The keystone had disintegrated, vaporized by the blast, and without it the arch had no structural integrity. Both sides of the span collapsed inward, the limestone blocks tumbling into the river in sequence like a falling curtain, each block pulling the next one down in a progressive failure that consumed the entire center span in less than 3 seconds. And the Tiger, engine still running, commander still in the process of closing his hatch, dropped nose first into the gap. It fell 20 feet. The front glasses hit the riverbed at approximately 40 miles per hour and plowed a furrow 6 feet deep, the impact shearing off the driver's compartment and folding the bow plate back against the turret like a crushed tin can. The engine deck landed on top of the rubble pile, still trailing exhaust, and then the river took over. Water poured into the crew compartment through the buckled hull, flooding the fighting compartment in seconds, drowning systems, drowning men. The tank settled, canted at a 40-degree angle, half submerged, treads still turning slowly in the current as if the machine didn't yet understand it was dead. No one got out. The driver and bow gunner died instantly, crushed when the glasses plate collapsed. The commander, loader, and gunner died in the water, trapped in a steel box that had become a steel coffin, unable to open the hatches against the current, unable to breathe as the river filled their lungs. It took 4 minutes, 4 minutes of struggling in darkness, 4 minutes of clawing at hatches that wouldn't open, 4 minutes of knowing exactly how you were going to die and being unable to prevent it. German engineers attempted to recover the vehicle on February 19th using a 16-ton FAMO prime mover and a steel cable rated for 20 tons of lateral pull. The cable snapped on the third attempt, recoiling across the riverbank with enough force to take a man's head off if he'd been standing in the wrong place. On February 23rd, they tried again with 2 prime movers and a floating crane barge brought down from Rome at considerable logistical expense. The crane tipped when they tried to lift the tank, the barge capsizing and spilling 3 tons of equipment into the river. On March 2nd, they gave up and built a pontoon bridge 60 meters upstream, accepting the delay and the vulnerability and the extra fuel consumption rather than waste more time on a corpse. Allied intelligence cataloged the wreck as Tiger 1 Offensive. Tactical number 221, destroyed by demolition, crew KIA. Toffey received the Silver Star for gallantry in action. Courtney received the Bronze Star with V device and a week of medical leave for cold water immersion injuries, including borderline hypothermia and minor frostbite on 3 fingers of his left hand. Neither man talked much about the bridge. In the official after-action report filed by the 36th Engineer Combat Regiment on February 20, 1944, the destruction of the Aprilia Bridge occupies exactly 3 sentences in a document that runs to 42 pages, covering the regiment's operations during the entire month. The report describes the method as improvised adhesive demolition charge placed by swimming approach, and notes that the technique achieved complete structural failure with minimal explosive mass and 0 friendly casualties. It does not say the technique was unprecedented. It does not say the Army had never trained anyone to tape a bomb to a bridge and swim through enemy territory to place it. It does not say that Toffey invented the tactic in a foxhole with a roll of tape and proved it worked by killing a tank the Allies couldn't stop any other way. But the Corps noticed. By March 1944, field-expedient adhesive demolitions had been incorporated into the training syllabus at Fort Belvoir, the Army's primary engineer school in Virginia. By June, the technique appeared in a classified supplement to FM 525, the field manual for explosives and demolitions, under the heading Non-Standard Placement Methods. By August, OSS operatives in France were using adhesive charges to sabotage rail bridges behind German lines, taping composition C2 to stone piers and detonating the charges with time delay fuses while resistance fighters provided cover and misdirection. By December, the British were doing the same thing in Belgium, using adhesive demolitions to destroy canal locks and deny waterways to German logistics. The technique spread because it worked, and it worked because one American engineer refused to accept that standard methods were the only methods. The war moved on. The Anzio beachhead held. On May 23, 1944, the Fifth Army broke out of the perimeter and linked up with forces advancing from the Gustav Line, ending the stalemate that had cost 14,000 Allied casualties and an unknown number of German losses. On June 4th, American troops entered Rome, the first Axis capital to fall. The 36th Engineer Combat Regiment moved north, building bridges faster than the Germans could blow them, clearing mines from highways, corduroying roads through the Apennine passes, keeping the advance moving through terrain that favored defense and punished attackers. Toffey survived the Italian campaign. He survived the winter of 1944, which killed more American soldiers from exposure and trench foot than from enemy fire. He survived the Gothic Line, the Po River crossing, and the final German collapse in April 1945, when the Wehrmacht in Italy surrendered en masse after running out of fuel, ammunition, and reasons to keep fighting. He went home to Pittsburgh in September 1945, resumed his job as a construction foreman, and spent 30 years building highways across Pennsylvania, retiring in 1975 with a pension and a reputation as a man who knew his trade. He never mentioned the bridge. Courtney went home to Santa Monica, took a job as a swimming instructor at the municipal pool, and taught 2 generations of California children how to tread water and read a riptide and survive if the ocean turned against them. He never mentioned the river. The tape became legend. By 1950, duct tape, later rebranded as duct tape after manufacturers shifted focus to HVAC applications in the booming post-war construction industry, had become a staple of American life, used for everything from sealing air ducts to patching torn tarps to temporary automotive repairs to 1,000 other applications that weren't in any manual. Its versatility became proverbial. Its strength became a punchline. But it had started as a tool of war, developed to solve a logistics problem in the Pacific Theater, and repurposed by a combat engineer in Italy to kill a tank. The Tiger at Aprilia was one of 14 confirmed Tiger losses in the Italian theater between January and June 1944. 7 were destroyed by air attack, 4 by direct fire from M10 tank destroyers, 2 by mines, and 1 by bridge demolition. Official kill credit went to the 36th Engineer Combat Regiment. Individual credit went to no one, because that's how the Army worked. But the Germans knew. In a February 1944 tactical report recovered from the 26th Panzer Division archives after the war, an officer whose name has been lost to history wrote, "American engineers are employing unconventional demolition techniques that do not conform to known doctrine. Bridges previously considered secure are being destroyed without visible preparation or warning. Recommend increased vigilance and expanded security perimeters around all critical infrastructure." Increased vigilance didn't help. You can't watch the underside of a bridge while you're sitting on it, and you can't guard a riverbank for 300 meters in both directions without exposing yourself to counter-sniper fire. The lesson of Aprilia wasn't about explosive power or tactical surprise. It was about improvisation in the face of constraints. The Allied victory in Europe is often credited to industrial capacity, the ability to produce more tanks, more planes, more ships than the Axis could match, to replace losses faster than the enemy could inflict them. And that's true. American factories built 88,000 tanks during the war. German factories built 25,000. The numbers tell part of the story. But numbers don't mean anything if you can't apply them at the point of decision. Toffey's bomb weighed 12 pounds. A standard American anti-tank mine weighed 20. A satchel charge used for bunker demolition weighed 35. A shape charge designed for anti-tank use weighed 40. He won with less explosive, not more, because he put it in the right place, using a method no one had considered standard. Because he understood structures and stress and failure modes, and applied that understanding in a way that maximized effect while minimizing risk. That's the engineer's advantage. Not firepower, not numbers. Thinking. The war produced thousands of moments like Aprilia. Small, nameless actions that never made the headlines, but cumulatively determined outcomes. A radio operator who stayed at his post during an artillery barrage and called in the coordinates that stopped a counterattack. A supply sergeant who rerouted a fuel convoy around a blown bridge and kept an armored column moving for another 6 hours. A medic who walked into machine gun fire to retrieve a wounded man and kept a platoon at full strength for the next engagement. History remembers Normandy and the Bulge and the Rhine crossing, because those operations had scale and drama and clear outcomes. It forgets the engineers in the river. But wars aren't won by the operations that make the newsreels. They're won by the ones no one photographs, the ones that happen in darkness and silence, the ones that solve problems too small to report, but too important to ignore. By 1960, adhesive demolitions had become standard doctrine in every NATO engineer manual. Soviet combat engineers adopted similar techniques after observing American methods during joint occupation operations in Germany. The Chinese used adhesive charges during the Korean War, taping explosives to bridge pilings along the Yalu River to deny crossing points to advancing UN forces. The idea spread because it worked, and it kept working because it was based on sound engineering principles rather than doctrine or tradition. Toffey died in 1979 at age 63 of a heart attack while supervising repairs on the Fort Pitt Bridge in Pittsburgh. His obituary in the Pittsburgh Post-Gazette mentioned his service in Italy but gave no details, listing him as a combat engineer who had earned the Silver Star and returned home to build the infrastructure that connected Pennsylvania to the rest of America. Courtney died in 1998 at age 75 in a nursing home in Santa Monica, where he spent his final years telling stories about the beach and the children he'd taught to swim, and the summers that had felt endless when he was young. His obituary in the Los Angeles Times called him a beloved swimming instructor and community figure who had touched thousands of lives. It mentioned he had served in World War II, landing at Salerno with the 36th Engineer Combat Regiment. It did not mention he had swum under a Tiger tank with a bomb strapped to his chest and lived to tell no one about it. The bridge at Aprilia was never rebuilt. If you visit the site today, and almost no one does, because Aprilia is a small agricultural town with nothing to attract tourists and the bridge is half a kilometer from the nearest road. You can still see the limestone abutments on both sides of the Gari River, standing like broken teeth, weathered by 70 years of rain and wind and indifference. The center arch is rubble, overgrown with weeds and small trees that have taken root in the spaces between stones. The approach road has been rerouted half a kilometer downstream, where a modern concrete span carries traffic that no longer remembers what happened here, no longer knows that 5 men died in a river because one side wanted a bridge and the other side wanted it destroyed. There's no plaque, no monument, no marker that says an American engineer changed the way armies think about demolition by wrapping a bomb in tape and trusting the river to carry him home. But the technique survives. It's taught at Fort Leonard Wood, where Army engineers train today, learning the same principles Toffey applied in that drainage ditch in 1944. It's in the field manuals used by combat engineers in every NATO country, written in technical language that obscures the human decisions behind the doctrine. It's in the training exercises where young soldiers learn to think creatively, to question assumptions, to recognize that the textbook answer might not be the best answer when terrain and enemy and circumstances demand something different. And every time an engineer looks at a problem and thinks, what if we did it differently? Every time someone refuses to accept that impossible just means no one has tried the right approach yet. They're standing in the same ditch where Toffey stood 81 years ago, watching a tiger idle on a bridge and deciding that the rules existed to be understood and then intelligently broken. That's the legacy. Not the medal, which sits in a box in someone's attic, tarnished and forgotten. Not the after-action report, which molders in an archive that no one reads. The willingness to improvise when doctrine fails and circumstances demand it. The understanding that engineering is fundamentally about solving problems with limited resources under difficult conditions. The recognition that sometimes the best weapon isn't the biggest or the most expensive or the most technically advanced, but the one that applies force precisely where it matters most. The Tiger at Aprilia weighed 65 tons, cost 650,000 Reichsmarks, and required 3,000 man-hours to build. The idea that killed it weighed nothing at all.